My name is Tim Gettings, and this is my final project for CSCI E90 Cloud Computing and the Internet of Things. My topic is AWS IoT with Arduino Implementation. For this project, I wanted to be able to determine the open-close state of my garage doors downstairs from my upstairs bedroom. I knew I could use a mercury switch or a magnetic switch or even an ultrasonic ranger. There's different cons with each of these approaches, but I really wanted to use a laser. Who doesn't like a good laser project? My intention is to mount the Arduino microcontroller next to the garage door controller, shine the laser beam from it to a mirror mounted on the doors, reflect that laser beam back to a receiver on the Arduino, and when that beam is continuous and reflected, the door is closed. When the beam is interrupted by the door being open, the door is open and it writes a update to the AWS IoT shadow. I decided to use an Arduino UN because it actually has Wi-Fi built in and actually two processors. One of them runs a small version of Linux. When power is supplied via the USB port to the Arduino UN, it activates an onboard Wi-Fi adapter and becomes an access point. You must browse for the SSID of Arduino UN with the serial number and connect to it from a PC. It will then supply an IP address to the PC via DHCP on the 192.168.240.0 network. You can browse to 192.168.240.1 to set up the Wi-Fi parameter to connect to your local network. The default password is Arduino. Here you see the screens. You enter your local Wi-Fi configuration here, including your SSIDs, passwords, etc. Next, I downloaded the Arduino IDE from this website here. Then I started the IDE. You can also configure and test the Wi-Fi config by running the UnShield Assistant. I'm showing that here. Here's the UnShield Assistant running. This is the serial output where you can also enter your SSID and passwords. Now, it also gives us the new IP address here. This is on my local network 10.10.22.128. I can use PuTTY to establish an SSH connection. Here you see me logged into the Arduino device. Now I'm going to run opackage to update, check for updates. Now I'll install Python and OpenSSL. Next I need to install pip to make it easier to install my GitHub packages. Do that by easy underscore install pip. Then I use pip to install the AWS SDK. And then here we see the install finishing. The AWS IoT SDK and sample code is available at the address mentioned here. Now we can create our thing on the AWS Amazon website. First we log in or create an account. Then we need to navigate to AWS IoT. Here we go to connect and then we click on starter kit. On the next page we click connect on Linux and now we name our thing. Here I named it TG Garage YUN. Be sure to download a connection kit. It includes the keys and certificates you will need to access your thing. That's very important. And here's where you download that. Download connection kit for this button. Here are the contents of my connection kit. Private key to public key certificate and a start program script. We will need to copy these up to the Arduino. I use WinSCP. Now we'll start the Arduino IDE again and write the program to monitor the laser and write changes to the desired and reported shadow update state. First we need to input our certificate key information. And that's in the AWS IoT config.h file here. And I based this code from the basic pub sub example that came in the SDK. Here you can see my endpoint. Got that received that from the AWS website. Client ID, my thing name, certificates, etc. Now we write the code. The code's attached separately. And we upload the sketch to Arduino and we read the doors being open on the next page. Note the debug info from the terminal. Let me show you this. Here's the program itself. Here's my debug output showing the door being opened. Here's the shadow from AWS showing the desired state open. Here the door is closed. You can see on the AWS it shows it being closed. Now we'll turn to the Raspberry Pi so we can use it to show us the garage door state. First we need to download the AWS IoT Python SDK, and here's the website to get that. We'll expand and upload the SDK using WinSCP. I'll use WinSCP to transfer it up to the Raspberry Pi. And here we're doing that. Now we need to check to be sure Python is loaded by keying the Python command, getting the version, and yes it is. Now we will write a Python program to monitor the shadow delta. That's a change between the desired and reported state using Nano. Nano is simply an editor like Vi. Here's a sample of the first screen. Again, I based the code on the basic shadow delta listener sample code from the SDK. Added the GUI function using TK-enter and modified the code. Again, that's a separate attachment. Now here, the door is open, and here the door is closed. The graphics are on the buttons. I intend to add the code. On the buttons, I intend to add code so I can close the door by pressing the open button. It will send the desired state of close back to the Arduino and activate a relay attached to the door controller to actually close the door. And of course, who doesn't like a good James Bond laser? Maybe it's not quite as powerful as the one used here, but it is a real genuine laser. Here's the assembled Arduino box with the attached laser running the program here. You see here's the beam reflected off my hand. Here's the Raspberry Pi running the monitor program. And now I'll show you a demonstration.
Here on the screen you'll see the output from the terminal monitor from the Arduino again. This is some debug information I'm putting out closed because the door is in the closed position right now. Here's the shadow document behind it showing also the desired state of being closed. If you look on the video here, you'll see the laser transmitter, laser mirror at the other end. I have the little Raspberry Pi device here, but the glare was so bad on the screen I will show it on a terminal, RDP terminal connection to show you what's happening there. So if I interrupt the beam with this device here, you'll notice on the screen it goes to open. The shadow document also goes to open. Oops, I lost it there. It goes to open. Now, if I let go, it should go back to closed. You'll see here it goes to closed here, goes to closed here. Now I'm going to swap over and show you an RDP connection into the Raspberry Pi Python program that's connected to the shadow document. It's closed now. I'm going to take the my daughter's selfie stick, interrupt the beam, it goes to open. If I let the beam go again, now it goes to closed state. And there you have the demonstration. Here we see the Arduino mounted on the wall in the garage. The laser beam shining across here to a mirror mounted over there. You see the ladder where I had to line it up. And I must say I greatly underestimated the challenge of lining up a laser beam 20 feet away on a mirror. But now if you look, I try to break the beam with my hand. I don't know if you can see it there. The LED going on and off.